calculator. But you can write, this is b is -5, so x equals the opposite of b. The formula will be over there, so you can write it accurately, nothing to worry about. And plus or minus square root, but we're just trying to avoid all the regular pitfalls. So, and then that's -5 squared, so this becomes -5 squared minus 4 times a is 1 and c is -36. The usual errors when you're doing quadratic formula are forgetting things like it's -36. It's pretty easy to miss right there, but it's the sign of the number is really important. It goes in there, it makes a difference on whether or not you have one solution, two solutions, or no solutions. Okay, I think I'm gonna go yellow highlighter, it's cooler. And then if you finish this off, I don't necessarily need a decimal. If it works out whole number wise, that's awesome. But it looks like 25 plus 144 over 2, and then it looks like a 169. Now this is a perfect square, and if you don't know those, I'll kind of acclimate you to some of those along the way. I don't mean for you to have to memorize them yet, but it's a good thing to know. But that would be the quadratic formula all kind of worked out. This is fine. Like these are like those are solutions that are in there, but it's one of those you go further if it's simple enough and feasible, or if it's part of what I ask. And I will ask for, if you can get whole numbers, get whole numbers. And 5 plus or minus the square root of 69. I'm going to roll up to the top here, so hang with me. 5 plus or minus the square root of 69 is 13 over 2a is 2. Remember, this is giving me the value of x that satisfy, or x, the two values of x that'll satisfy this initial equation. So the x's that work in here, okay, that make that true. So, you ready? So 5 plus 13 is one of them. So there's going to be 2. And the second one is 5 minus 13. Both of them divided by 2. And so that gives you your two x values. This is what I mean by kind of go through the whole process. I'm not interested in the decimal. Both of these work out pretty nicely. 18 over 2 is 9. We're going to talk about what these mean. That's negative 8 over 2, so negative 4. Okay. Talk about old school, good old quadratic formula. We were just watching this Netflix new release of a show, and she was reciting the quadratic formula. I talked to some of you about it, but it's awesome. The thing about it is that you can solve any quadratic where the degree of it is x squared is the highest power. You can solve any of those. The only thing you have to do is set it equal to 0 and use this formula, and it works. Radicals are cool. We like those. You need decimals, great. But there's the things about the 1, 2, and no solution is I also want you to connect that with that graph that goes with it. So it's a good time, grab your calculator if you have one. So I'm going to pull out mine here. And the idea of solving is finding out what satisfies the equation, and you can do it graphically. If you think of this expression of x squared minus 5x plus 36, I think of it as it's a graphed parabola, and what it's asking in the equation is when does it have a height of 0? When is it equal to 0? So that's the question. I'm going to graph that and see when is it 0. So here's my TI calculator. If you haven't used one in a while, grab one. And I know there's a tendency in some cases not to use them, and then every year somebody doesn't ever touch it in class, and they're like, Mr. Seeley, I don't know how to do this. And they come up on a test, and I'm not real inclined to help because they didn't try. But you really do have to mess up. Get ready to screw up your calculator a lot, because they screw up stuff for us. We need to give it back to them. Be tough on your calculator. So, y equals, that's where it all begins, if you remember this well. I have an expression in there. I don't know if it's accurate or not. It's a different one, I think. Yep, we're going to change it. But you want to clear things out. Whatever's in there will graph so long as the equal sign is highlighted. And the x that is in the equation is found on this xt theta n button, not the alpha x. So x squared, I'm going to use the squared symbol, and then minus 5x. Even typing it in there is not trivial. I don't know what your experience is with it. I know it's You've had some experience with past teachers, but in some cases not very much, and that's fine. But that's typing in the expression. And if I just hit graph, it kind of takes you to whatever window you last had graphed with. And that could have been 3 years ago, the last time you used your graphing calculator. So you never know what you're going to get by hitting graph. Sometimes you're lucky and it gives you a window that works. But, so mine works. I bet some of you, if you just hit graph, you get something different than what I have. It'll look totally different. So it's not about graph, it's zoom. That zoom button is where you have, think of it as like your camera lens, it's where you kind of focus in on what you want to see. And the standard, zoom standard, is standard. And so that's what we look to most of the time. It's a window, you're 10 to the left, 10 to the right, 10 up, 10 down. So we tend to start there and then kind of work our way out. But that 6th option, zoom standard, is pretty common. You can type 6, or you can scroll down to it. Okay, so that would be zoom standard, and hit enter. That gives you that 10 by 10 by, and then that means we all get the same window. It should all look the same unless something was typed different, and that's normal. Ta-da! So look at this though. That solutions that we just got, they play a part in the picture. We found where this expression, this quadratic expression that I just graphed, you graphed the part that wasn't 0, we found out when it's equal to 0 is when it has a height of 0. It's these roots. We call it the zeros. And it's -4 and 9, the two things we got from the quadratic formula. So in this setup, when we set it equal to 0, we're actually asking, hey, when's the picture of this expression have a height of 0? When does it match? And this is 2 solutions. If we look through quadratics, and we'll do it here in a minute, quadratics can have 1 solution. They can have no solutions. And those look like, if I put it on my screen here, and this is just a little outline, you can, with a quadratic, oh, right in highlighter, that's good. But the quadratic, it's a parabola when you graph it. It can have 2 solutions. And we just saw a picture of that where it hits twice. It can face up or down, doesn't matter. And then 1 solution is, remember this one picture? It bounces. Doesn't matter which way it faces, but it only touches once. Sometimes it bounces off of there. It's important. 0 solutions just floats up in the air, doesn't touch. It'll touch the y-axis just fine, but it's not touching the x-axis anywhere. Those are the 3 scenarios. And the quadratic formula will show those. Like you'll get a no solution, and it's not 0 solutions, it's actually 0 real solutions. So I'm going to add that little important addendum, because it's not that there aren't solutions, it's just they're not real numbers. They're imaginary numbers. 1 solution is touching once. Okay. That's a lot of information that's going on in there. But let's go to one that has purported, like 23, no solution. Should we try it out? If I go to my quadratic formula, I get all excited. You go x equals the opposite of b. So I go 4 plus or minus the square root of b squared minus 4a times 10 is c, and all over 2 times 2. Done. That's the setup. You don't have to memorize it. Please use it accurately. It's behind on the wall. But more about accuracy than anything. Then when I do this, that funny thing happens. 16 minus what's going to be 80. This piece makes 80. 16 take away 80 is -64. And this clues us into having no real solutions, because square root of a negative is what produces imaginary numbers. It's not a bad thing. They're not fictitious. They're not make-believe. It's just that imaginary numbers are necessary in solving polynomials, and they occur, and it got a name, a really bad name. So I'm sorry. They're very real things. They're not imaginary at all. They just have a... We'll work on that. Maybe we can petition, do something. It would be kind of a neat way for you guys to kind of hit the pavement and do something good for the math world. You up for that? You guys handle that. By the way, this makes 8i. Isn't that cool? Remember, you just do 8i. Square root of 8 is 8. Square root of 64 is 8. It has an I because it was the -64. Nothing fancy. We'll get into the details of all that, but that, I think, helps. It's just a way of getting at a solution. There is a tendency, this is okay, but generally we take these and we divide both terms by 4. That's an important thing. When you have two things being divided by the same number, you can split it, and you get 1 plus or minus 2i. And that's an old algebra trick. This is Grotehouse emailed, as you can see. So, though, and the plus or minus again means there's two different solutions. X could be 1 plus 2i, and x could be 1 minus 2i. Just so you know that imaginaries aren't imaginary at all the CGI graphics, computer graphics stuff is done using an imaginary plane, and they use imaginary numbers to make very real images. The irony. Oh, the irony. Okay. Shall we? I think that helps, but now look at that. That means no real solutions. We're going to graph this with my super duper graphing calculator and see what it means to have no solutions graphically, because that would be really important to note. It's just an indicator of some kind of behavior. It tells you what's going on. I like to know what's going on. You know? That's why I like math. It tells me what's going on. So minus 4x. You're in the know. Graph it. In the y equals. Hopefully zoom 6'd it. Oh, if you don't see it in the window, try zoom 6. The cool thing is your calculator doesn't know what to graph until you tell it. So our knowledge of graphs becomes important because we won't be able to even find that picture in some cases unless we know what we're getting into. You have to have a sense of what it looks like ahead of time. So get ready. We're going to beat this dumb calculator. Get motivated. It looks like this thing right here never touches the x-axis, and that means there are no real solutions. There are solutions, but just not ones that touch the x-axis. There's no x that is missed that doesn't have an I that works in this one. But that's okay. We like it. Ta-da! There is a lot to go into this, and I have tomorrow 2 more big topics with you.